we're still working with mathematical induction, so let's just go ahead and dive in on this one. Step 1 on mathematical induction. We need to prove this is true for S sub 1. So to do that, we're going to take this little part, and we're going to put in a 1. And then we're going to come over here on the right side, we're going to put in a 1 and prove that it's true. So 2 to the 0, and then that's going to be 2 to the 1 is 2 minus 1. So 2 to the 0 is 1, and 2 minus 1 is 1. So that works. So we have the proof there that S sub 1 checks out. All right? Step 2, prove that it's true for S sub k, which basically means write down your sequence with k's instead of n's. 2 to the k minus 1, and then we have 2 to the k, and then a big minus 1. So be really particular about what's in the exponent and what's not, otherwise it could get highly confusing. Okay, that's all there is to that step. Next step, prove that it's true for S sub k plus 1. Okay, so we have to go, I'll tell you what, let me shrink my pen just a little bit. Well, at least I thought I did. I didn't. Okay. That may be too small. If we come in here, I need to write down my entire sequence. I guess my pen is too small at that point. You guys can't see it. I need to copy the entire sequence. But remember, when you're doing the k plus 1 term, you have to add the next term on the left side. So at this point, you're coming in and you're putting in a new term. You're adding it where you're putting k plus 1 up here. And then you're going to go back to writing it. But over here, you're going to put k plus 1. And you're going to work it out. So those are the two changes. You actually have to add a term on the left. And you have to put the k plus 1 portion in where k would be. So wherever k is over here, you have to put k plus 1. And then same thing on the right side, wherever k is, you have to put k plus 1. Now, remember, you have to show that all of the stuff on the left is equivalent to all the stuff on the right. Well, there's much more stuff on the left because it's an entire sequence. So you have to do some substitution because, I mean, you have all this dot, dot, dot business in here. So keep in mind that you know that that entire sequence is equivalent to 2k minus 1. So keep in mind what you're swapping out. All of this. And I mean, quite honestly, it's just not a bad idea to underline it. That's what's going out. So you're swapping all of that for what's here in the box. So take every bit of what's underlined and replace it with what's in the box. 2 to the k minus 1. Now add, start right here, plus 2, and then notice, I'm going to get 2 to the k, but my 1's cancel out, so I don't need those. Now, on the other side, I have 2 to the k plus 1 minus 1. Now, this is where you kind of have to have faith, keep working. It's going to be fine. Because whenever you start working with this, it's kind of a little weird. I have 2k plus 2k minus 1 equals this. And it looks really, really close, but it's not perfect. Well, another way of writing this portion right here is 2 2k's. 2 to the k's, right? Well, now that you have it written that way, you can use exponent rules, which is what we need to correlate it to this part over here. Isn't this 2 to the 1? Well, now that I have that written as 2 to the 1 and 2 to the k, the rule is to multiply like bases, you add your powers. So I write the base one time, and I'm going to add my powers. I'm just going to add them with the k first. K plus 1, and then I have minus 1. Well, lo and behold, that's exactly what I wanted. So it does check out. A little weird, but he checks out. So we have that one done. Okay, let's see if we can do one more, just so that you guys have another example that you can work with. Let's see here. This one will work. If you do mathematical induction with this one, same process. Let's do S sub 1. Again, we're going to go through and we're going to have a tiny little thing over here on the left. 1 squared equals, and then we've got 1, and we have 1 plus 1, and we have 2 times 1 plus 1 all over 6. Well, 1 equals 1 times 2 times 3 all over 6. Well, technically that works, because 1 equals 6 over 6. Yes, it does. That works. Okay, now S sub k. I've got 1 squared plus 2 squared plus 3 squared plus 4 squared plus dot 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 plus n squared, and here we go. I have n, oops, I'm wanting k, right? Oops, let me go back and do k's. Missed my whole point, didn't I? K squared. Then I'm going to do k plus 1. Then I'm going to have 2k plus 1 all over 6. There we go. There's part 2. Now let the fun begin. Oh boy. We get to do k plus 1 with this one. Yummy. So, prove it's true for S sub k plus 1. And I'm going to just kind of back this up as much as I can. I know this is going to take up a lot of space. So, I have 1 squared plus 2 squared plus 3 squared. And let's just go ahead and start my little dots. That's going to be k squared, right? Remember, I have to add a term. I have to add my k plus 1 term. That has to be inserted. And then you're going to come over here, and on the right side, everywhere there is a k, you must put k plus 1. So this gets back to the grouping symbol stuff that I told you. If you already have parentheses, it would be wise, insert brackets. So you have k plus 1, and then a plus 1. And then you have 2, k plus 1, plus 1. Alright, so you have a hot mess over there. That's basically what it turns out to be. So it's time to clean. Come over here, and you know that all of this is equal to this lovely little fraction on the right. So there's your match. So let's do the swap. Let's go ahead and swap it out. There he goes. And then all I have is I have k plus 1 quantity squared. Wow. And then I got a lot of cleaning to do over here. I have a k plus 1. And then this part right here, I have k plus 2. Because there's no need to keep the ones apart. Same thing here. Now be careful. It is different. I need to distribute my 2. So that's going to be 2k. That is going to be a plus 2, but with the 1, that's going to be a plus 3. So I did kind of skip a step on you. Sorry about that. Okay, now I've got to get this to where these meet. Looks like this is nice and worked out and in factored form. The denominators are great. I've got a 6 and I got a 6. But this is one nice fraction. Over here on the left, no, I have 2 separate terms. So I need to get a common denominator. So to get a common denominator, this one, I don't have to do anything to him. All those terms just sit there. But over here, his denominator was 1. So to force the denominator to be the same, don't you just do 6 and 6? So I need 6, k plus 1 squared, and that'll make this a common denominator. Now I need to do a little maneuvering here to get this to work out. You can actually factor. If you notice, you have two terms because it is added. I have a k plus 1 here and I have a k plus 1 there, so I can factor this out. I have k plus 1. I'm going to factor out k plus 1. That leaves k and 2k plus 1. Now on the other side I have plus, and then I'm going to have 6 k plus 1 all over 6. So you kind of have to hang on to your halo there, but we were factoring out the k plus 1s. You just factor it out like it's one great big term. You just factor it out a binomial. No big deal. Okay, now we're still trying to get everything sorted out. Let's get a little bit more space there. The k plus 1 looks great. Oops, I wanted to move it and I moved it a lot. Uh-oh. Well, there we go. I lost my scroll bar there for a second. Okay, here we go. I've got k plus 1. He's looking good. And I got my 6. He looks good. The inside of these brackets is a mess. So they just need to be distributed because this plus sign here, I have two separate terms. So distribute the k, and that's going to be 2k squared. K times 1 is k. Now get over here and distribute the 6. So that's going to be 6k. And 6 times 1 is 6. Alright, so keep k plus 1 outside. He's just sitting there chilling. And that's going to be 2k squared. And that's going to be 7k plus 6 all over 6. Now, time to factor. Alright, when you factor, that's going to be 2k and k. And I need two numbers that multiply to 6. Now, I need my middle terms to add to 7. So I need the 2 here and the 3 there. That'll give me 3k and that'll give me 2k, which adds to 7. Signs are the same, both plus. All over 6. Now we scrolled it off the page, but guys, that's exactly what we needed. We can bring it all the way down here and match. We may not have everything in the right order, but we have all the right terms. We have proved that it works. Yeah, we've got our terms reversed here, but all of the terms are there. We proved it for s sub k plus 1. It's there. We did it. So as nasty as it was, it's there. So you can do mathematical induction. Just hang in there. Got to exercise your algebraic muscle.